Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm going to do a little special video kind of talking about my electrical system here in the shop. This is a video that has come in a request from actually several of you guys that are watching my channel, wanting to know how I kind of tackle some of the electrical problems that you run into anytime you're building a new shop. So if you're getting ready to build a new shop and you're going to have a lot of equipment in it, have a lot of power needs, I'm going to tell you how I went around solving it in my shop. Now first, a little bit of information about my shop. My shop is 42 feet wide and about 80 foot long. It's kind of built like a barn. It has a center section that goes up to the top with a clear story in it, and then two side sheds that come down on each side. It is kind of a post and beam construction on the inside, which provided some challenges when it came to wiring, because with that raised section in the middle and having the large posts and beams in it, it really made it difficult to run wiring through those areas from one side of the shop to the other side. It wasn't impossible, but it was difficult. But we got around it, and I'm going to talk a little bit about some of that. Now, before I get too deep into this video, I need to make some things perfectly clear. Number one, I am not a certified licensed electrician. So I'm probably not qualified to give you guys too much advice on how to do electrical wiring. What I'm trying to do with this video is just kind of talk to you a little bit about how I solved some of the problems that I had that came up in this. If you are not familiar with electrical wiring, I would highly recommend that you get with a certified and licensed electrician to do that. Also, I'll note that in some parts of the country, and at least here in the US, it is illegal for a non-licensed person to do any electrical work whatsoever. In other places, it is not. Where I live at in Georgia, I live in a rural area in Georgia, we can legally do our own electrical work as long as we are doing it for ourselves. I'm not doing it for someone else. I'm not receiving money for doing that work. So everything in here I went to my permit office, told them what I was doing. They told me what I could and couldn't do, etc. It was inspected by our county inspector and everything else before it was said and done. But I did all of my own electrical wiring. Now, while I'm not a certified electrician, a licensed electrician, I do have a good bit of experience with it. I actually worked for a licensed electrician for many years back a long time ago, learned the basics, learned how to do a lot of what needed to be done. So, trust your own judgment on this. Understand your local rules and codes. Now, when I did this shop, I tried my very, very best to keep it up to the National Electric Code, the NEC code. Keep in mind that that's kind of the bare minimum. Many states, many localities will have codes above and beyond what is required in the national NEC code. Again, where I live at, the NEC is pretty much the Bible. I've got a copy of the book right over there on my bookshelf, and I was able to look things up. And I also had the advantage of having several friends who are licensed electricians that I could call along the way and ask some questions, which I did on several occasions. So this is kind of the front entrance to my shop. And if you look out here, you see my meter base on the outside of the shop here. I currently have a 400 amp service coming into the shop. When I first built the shop, it was a 200 amp service, and we later upgraded it. And I'll talk a little bit more about that in a minute. But you see here we have underground service. I don't know if you can see it or not, but up in front of that pump house, probably about 50 yards away, is the transformer that for my house. So when I called the power company, they were able to come out here, ditch in an underground cable, and come up to this particular meter here. And on the inside, right behind that, is my main breaker for the inside of the house. Now again, when I first built this shop, I had 200 amp service, and then later on, after I got a phase converter and some other things, a big air compressor, and had plans for a big air compressor anyway, I started second guessing and said I should have gotten 400 amps in here. And I called my power company up, and they looked at what they had run down here. They said the wiring was adequate for, the underground wiring was adequate for 400 amps, and we upgraded to 400 amps. Basically, when I did that, we just replaced the meter base. Had to change some wiring out in there. Of course, everything had to be disconnected and turned off. But again, on the very back side, this is my main panel for inside the house. Right next to it here, right next to it is another breaker box here, and this is another 200 amp breaker, and it actually has an underground that goes to another panel that is pretty much just used for running my phase converter, my air compressor, and a couple of other things like that that are pretty high load. So while I have 400 amps into the shop, it's basically divided into two 200 amp panels that distribute the power throughout the shop. So this is the main breaker box or load center for my shop. And again, directly behind this is the meter on the outside of the shop. By code, your first panels with a disconnect have to be within so many feet of the meter. So in my case, both of my 200 amp panels are literally within a foot or two of that meter. And both of them have a main disconnect in them that can be turned things off. In the case of the outside one, it actually feeds a sub panel, but I needed to, by code, have that disconnect right next to the actual meter, if I remember the rules exactly right, and that's how I got around doing that basically. So in here, you know, basically we got our breakers that are going around to the different things in the shop. Now for my single phase power, most everything is just powering lighting and, you know, my receptacles that you would plug a plug in which you're going to use a lot of that in any shop. So pretty much everything's 20 amps breakers in here. I went ahead and did 20 amps on all of my receptacles around the shop, and I don't have one right here. I'll show a little video of it, but I basically put all of my receptacles about this height right here, where I can just reach over and plug it. If I have a counter up against it or whatever, it's high enough where it's not down too low and covered up. It's up right there, easy reach to easy heights to reach, and I really like that feature. I also did 2 duplex receptacles in every box, so basically 4 plugs on every box. Again, want to have plenty of power, and I space those about every 10 feet all the way around the any walls that I had in the shop. So the exterior, and there's a center wall in here as well. And for the most part, I got two duplex receptacles in each one. There are a couple places where I just had one. As far as how many I put on there, basically I think it was 2 receptacle or 2 stations, so a total of 8 receptacles per 20 amp circuit. In 6 or 7 years, I haven't ever tripped a breaker, so I think we did pretty good there. We do have some 220 volt outlets right here. These are for welders. I have a welder that I use that I just plug in right here at the box, so not long runs to have to do. These are both 50 amp, and there's also a 100 amp breaker in here that feeds a sub panel that is on the other side of the shop. Now, I mentioned this I think a minute ago, but one of the challenges that I had in the construction of this building was that it was very difficult to move wires from one side of the shop to the other side of the shop because of the post and beam construction that I had in here. Basically, I'd have to drill through about an 8-inch thick timber to get wires through here, and I wanted to keep that down to a minimum. So my solution to that was that I've got a sub panel on the other side of the shop. This panel feeds this side of the shop, the sub panel feeds the other side of the shop. So we ran 100 amp wiring over there. It's all actually outside, buried. It comes back on the outside of the shop over there and comes back in to a sub panel. That has worked out extremely well. And while I did have, you know, probably 60, 70 feet of that heavy 100 amp gauge wiring to bring in that sub panel, because of the amount of wire it was going to take to have to go way up and over and run those circuits from the other side over here, I actually saved money in wiring when it was all said and done. I used considerably less wiring by having that sub panel on the other side of the shop. So something to think about if you have a similar situation. You can put a sub panel off of this main panel to do your wiring on one side versus the other like I did. So that kind of talks about the single phase component of my shop. It's pretty much done just like you would if you were doing an electrical installation in a home. This is all pretty much wood frame construction. Everything is ran mostly with Romex wiring. in the walls, and at least the 20 volt or 20 amp circuits and stuff, and pretty much just like you would in the house. And that has worked out extremely well for me. But the other component that I have in my shop is that I'm using a lot of industrial grade equipment that requires three-phase power. So most residential homes in the US only have single-phase power coming into it. You basically have two hot leads coming in, 110 volts each. You can get 220 volts by combining those 210 leads coming in. With three-phase, you have three hot lines coming in, and with those you can, basically have a situation where you have more efficient motors and motors that can run on lower amperage, higher horsepower motors on lower amperages using smaller gauge wiring, and they're generally a little bit more efficient than a single phase motor. Most industrial grade machines are going to use three-phase power. Three-phase power, again, in the US for the most part is not available in residential areas. There are exceptions to that. But even if you can get three-phase power into your home shop, oftentimes you're going to have to pay industrial rates for that power, which can get rather expensive. So the way that I got around being able to put in all of my big industrial machinery is I need to be able to generate that three-phase power. There's lots of different ways to do it, or maybe not lots, there's several ways of doing it. In my opinion, some ways are better than others. In my application, I felt like the best thing for me to do was to get a large rotary phase converter, which basically is a device that will generate three-phase power from single-phase power. I won't go into how it works, but it works, and it works well. So for my three-phase power, again, we got the second 200 amp service coming into this sub panel. It goes down underground, comes around the side of my building, and I actually have my sub panel over here with that full 200 amps in it. And this sub panel pretty much only powers my phase converter, my air compressor, and yeah, I got a little outlet here you can plug a camper in as well. I've had a couple of times we've had a camper to plug in, but that's pretty much all that's in there. This is my kind of high use, high demand units, and they're all on a separate panel by themselves. Now right below this is my American Rotary 40 horsepower rotary phase converter. This is their unit that is designed for being outdoors. It is in a waterproof container. Everything is, again, these things are made for working in agriculture out on irrigation systems and stuff like that. So it's perfectly fine being outdoors. That clears up some spots, some inside my shop, some room where I don't have this thing in there. Also, although it doesn't make a whole lot of noise, it puts all that outside. Over here on the front panel, there's a switch where you can turn it on and off. And that three-phase power is being generated there, and put it back there as it turns it off. From the three-phase converter, again, we go back in, and this is where the three-phase power enters my shop. And you'll see in just a second, we have a load center on the inside of the shop right behind that. So directly behind where the power comes in to the shop, we have yet another breaker box load center here. This one, however, is a three-phase panel. It is designed for three-phase power. So if you look in here, the breakers, basically there are 3 poles on each breaker. 1 pole for each of the legs that's coming into the shop. So basically I've got each one of these is 110 volts, just like you would have in a single phase box, but each one of these are on a different leg of that three-phase power. Theoretically, if I had three-phase power coming in the shop, we would just have a three-phase panel, and you can run all of your single-phase stuff off of this. You just put a single pole breaker in there, and you've got your line to put in your receptacles or whatever. If you got 220 volts, you put in a double pole breaker, and for a three-phase circuit, you put in a 3-pole breaker. However, because I'm only running three-phase equipment out of this panel, I've only have three-phase stuff going in here. So every breaker in here is a three-phase breaker. For the most part, my shop is ran with 20 amp circuits. I do have a couple of 30 amp circuits for some bigger machines that are running like 10 horsepower motors, but pretty much everything else is on a 20 amp breaker. Now if I shut the panel over here, this is one of the receptacle boxes that I have for three-phase. It's a little twist lock type connector that you can go into, and you can get these for both 20 and 30 amp circuits, no problem at all. Now for running my wiring, you'll notice we have conduit coming out of this box. I did run conduit. All of my three-phase stuff is in conduit and it is mounted to the walls. So down this wall here, I notice I got a, I don't know if you can see it or not, but there's a piece of conduit that goes out. And I can't remember how far I spaced them, probably about every 10 or 12 feet. I've got a single phase or a three-phase outlet spread out all around the shop. And that has given me the ability that I can pretty much plug in whatever I want, wherever I want to. And on these, I think I've got two these receptacles on each 20 amp circuit, which is generally adequate. Most of my machines are not drawing 20 amps. You know, 5 horsepower motors, I'd have to look it up. It's probably only drawing 7 or 8 amps. So you can easily run more than one machine off of one 20 amp circuit unless you've got a higher horsepower motor that requires a higher input. One of the nice things about running all this stuff with conduit is that I can fairly easily change things or add new circuits. I don't have to go into the wall to do that. And there have definitely been some cases where I brought some machines in and needed power in certain places. Not a big deal. I've got extra slots in my panels here where I can bring in more circuits as needed, or a heavier circuit or whatever, just run another piece of conduit to it. Now I will note that just like on the single phase power, we have in here a main panel right here, and then there's a sub panel on the other side of the shop. So we have a breaker here that feeds that sub panel, and that sub panel actually feeds all the three-phase power on the other side of the shop. And this system has worked out real well. Also note that right over here we've got a remote switch where I can turn that phase converter on and off from inside the shop, so I don't have to go outside and do that. There's also a light in here that lights up and tells me when it's done. And I have some of these remote start stations in 3 different places inside the shop to make it fairly easy when I need to turn that power on if it's not already to go turn it on. I also have some indicator lights that turn on whenever the phase converter's on, so I can easily tell whether it's running or not. Sometimes you forget whether it's on or not, so if you're getting ready to turn a machine on, did I turn my power on? I can pretty much look from anywhere in the shop and see one of those indicator lights and see if it's actually on or not. But that is how we basically distribute the power around to all my individual machines for three-phase power. I also wanted to spend a couple of minutes talking about the rotary phase converter that I'm using. And I mentioned that mine is made by American Rotary, and in full disclosure, they are a sponsor of my channel. The reason that they are a sponsor of my channel is because they are a quality company that I can feel like that I can stand behind, and that I know makes a very good product and has very good customer support right here based in the US. If you call them up with questions, you're not going to be talking to a non-native speaker on the other side of the world. So for people here in the US that speak English, you're going to be able to work with an American company right here in the US, specifically in Wisconsin. They make a great product. I'm very, very happy with the one that I have and have had now running in my shop for about 6 years without any significant issues whatsoever. So one question that always comes up though when you start talking about phase conversions or making three-phase power out of single-phase power, there is more than one way to skin that cat. And there's probably mainly 2 ways. There are more than that, but I will kind of narrow it down to the 2 main ways that people use to generate three-phase power using single-phase power. First is with a rotary phase converter. And I will warn you right now that there is a wide spectrum of quality in rotary phase converters that are out there. If you are somewhat electrically inclined, you can get a 3-phase motor, a motor starter, and a couple of capacitors, and etc. You can build your own phase converter, and it'll work. But the power that's going to come out of some of those is not going to be very well balanced. It's got some issues with it. In most cases, it works just fine. In some more sensitive equipment, it can be a problem. The beauty of the phase converters built by American Rotary is that they have gone in and they have very proprietary electronics inside of that really clean up that 3-phase power. It's constantly monitoring the voltages coming out of all 3 of those phases, and it's adjusting things on the fly to make sure that you have good, clean three-phase power coming out of it. And that's one of the biggest complaints I think I hear from people about phase converters. With American Rotary, you really don't have to worry about that. With some of the other phase converters that are sold commercially or homemade, you may or may not. So just kind of keep that in mind. The other main way that people use to generate three-phase power is use a device called a variable frequency drive. A variable frequency drive, or a VFD as they're commonly called, is really designed for three-phase input to give you variable speed. It varies the frequency of that power. Here in the US, our power is at 60 hertz, so every 60 seconds that alternating current is bouncing. Every second that alternating current is bouncing up and down 60 times. In some other parts of the world, it may be 50 hertz or something else, but again, here in the US, 60 hertz is what's standard. With a variable frequency drive, there is a potentiometer or a rotary dial on there that you can turn, and it will change the frequency of that electricity on the fly. It's really kind of slick, and it's primarily designed for giving you variable speed on a three-phase motor. That's what it's really designed for, is motor control. And a VFD can do a lot more. It can do motor braking, it can do soft starts, it can do all kinds of fancy things to control a three-phase motor. But people figured out a long time ago that you can actually cheat things a little bit by taking a VFD that's designed for three-phase power, and you feed it with 220 volt single phase power. If you got a 220 volt system, if it was 440 volt, it'd be different, but most stuff in home shops is going to be 220 volt three phase. So you can feed it with 220 volt single phase, put a jumper wire in there to the third lead, and it will magically convert that over to three-phase power. And it works great. I'm not going to say it doesn't. And I know lots of people, that's how they get around doing it. It's fairly inexpensive for a single machine. It's not a bad idea. In my mind, though, the thing you have to think about with VFDs is this. There is a point where you get so many machines, it becomes more expensive to put a variable frequency drive on every machine in your shop than it is to just get a phase converter and be able to power everything and not have to worry about it. And for example, I think I went around my shop. I've got 26 different three-phase machines in my shop. Yes, it's a fairly large shop, lots of different tooling in here. If I had to go buy 26 VFDs to run everything, because they're all different size motors, they all need to be sized differently, they be really kind of customized for the motor that it's on. To properly set up a VFD, you need to put the motor information that it's running. And while I'm not going to say you can't run multiple machines off of a single VFD, independently, it's really not practical in a lot of cases, particularly under certain circumstances. With the rotary phase converter, I don't have to worry about that. With a VFD, you're powering it with 220 volts single phase power. So in most of my shop, like I told you, I'm running 20 amps circuits, so I can use regular size wiring just like you'd use in a house. It's not super expensive, but when you start having to feed that VFD with the 220 volt single phase, where I'm running a 20 amp circuit to this machine, you might have to run a 40 amp circuit to it. So you're increasing the gauge of your wire, you're increasing your cost of installation, and it really can get kind of clunky putting in all those 220 volt circuits throughout your shop, and expensive too, if you have to do a bunch of different things. So there is a point where it's cheaper and more efficient to just buy a phase converter than it is to use the VFDs. I'm not going to say using a VFD is wrong. It has applications where it makes a lot of sense. But at least in my shop, a phase converter was a better option. And I would say that if you've got a shop where you're looking at, okay, I just bought a lathe or a mill, and if you really think that that's the last three-phase machine you'll ever buy, you're probably kidding yourself. Most people, when they get their first three-phase machine, they kind of break that barrier. They start realizing they can get industrial grade machine. They can buy used a lot of times cheaper than they can get the hobby grade equipment. And once they kind of get that ability to do the three-phase power in their shop, they don't have to worry about it anymore. So if you're in the market for a rotary phase converter, I, again, highly encourage you to talk to the folks at American Rotary. And because they are a sponsor of my channel, they do also offer a discount code to you, my viewers, that you can take advantage of if you decide to purchase a phase converter from American Rotary. That information is down in the description of the video. There's a link to the American Rotary website, as well as that checkout code that you can use to get up to 10% off on most of their phase converters that they offer. So again, if you're in the market for a phase converter, give them a call, talk to them before you make a decision, and we'll leave it up to you as to what you actually do. But I can tell you that they make a very good product, and again, they have extremely good customer support. Well guys, there's a quick and dirty video on how I approached solving my electrical problem in my shop to be able to run both single phase and three phase, and how I went about doing it. Is it the only way it could have been done? No, there's many ways that it could have been done. Is it the best way that could have been done? There's probably argument there that you can make. But in my mind, this was a good solution for my situation, and it has worked extremely well for me. I'm very happy with it. If I had to build the shop over again, I'd probably do the electrical system more or less exactly like I did. Is it the right way for you? That's a decision you're going to have to make for yourself. Is there a wrong way to do it? Well, the main thing is, as long as you keep it up to electric code, you're doing it safely, and you make sure that either yourself or the person that's doing your work for you knows what they're doing, you're probably not going to go wrong, at least not terribly wrong. Just try to think things through, figure out what's going to be best in your situation. And again, I'm not saying this is how you have to do your shop. This is what works for me, and I'm sharing what works for me in this video. And with that, guys, we're going to sign off. Again, thanks as always, everybody, for watching the video. Please subscribe to my channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there if you want to get notifications when new videos are posted. And a big, huge thank you to all my supporters of the site that support me through Patreon, PayPal, etc. We could not do everything we do out here without your help. And with that, guys, we're going to sign off. We'll catch you on the next video. Again, thanks for watching.